Well, it's time to start. It's 8 o'clock. So we'll look at something that is probably familiar, but maybe some new things will be learned. Let's start out by factoring a difference of squares, x squared minus a squared. Notice the greatest common factor of both terms is 1. So the person who's a beginner at factoring might not know what to do next unless they know the difference of squares factoring formula. So what we'll do is we'll add 0 to x squared minus a squared. If you add 0 to anything, the quantity doesn't change, but the form that 0 takes is going to have a special significance. So the form that 0 takes will look like minus ax plus ax. So all I did was put minus ax plus ax between the x squared minus a squared. And then we factor by grouping out of the first two terms. We factor out the greatest common factor, which is x. So we get x times x minus a. Then when we factor a quadrinomial, a 4-term polynomial, by grouping, we bring down the middle operator of addition. And then out of the third and fourth terms, we factor out the greatest common factor, which is a. When we factor a out, we get the binomial x minus a. And then the last step, the greatest common factor of these two products is the factor x minus a. So we factor that out, and we get x minus a times x plus a. So you can just remember how to factor a difference of squares by using this formula. If you have something of the form x to the second minus a to the second, then its two factors are x minus a and x plus a. You can always verify factoring by multiplying. Okay, the next one, factor the sum of squares. Well, we're going to factor the sum of squares by converting it to a difference of squares. So here we recall a definition. The imaginary unit I is defined as the square root of -1. And consequently, if you square I to the second, that's equal to -1. So we're going to rewrite x squared plus a squared as x to the second minus the quantity a times I squared. So if you square a times I, you get a squared I squared, but remember I squared is -1. So this is equivalent to x squared minus -a squared, which is the same as x squared plus a squared. Now that we have a difference of squares, we can use the difference of squares factoring formula. And we'll write the two factors as x minus a times I, and the other binomial is x plus a times I. Okay, next we'll factor the quadratic trinomial x to the second plus bx plus c. So what we're going to do in this case, we will add 0 again, and then using algebra and arithmetic, we'll convert this to a difference of squares, and then we'll factor the difference of squares using the formula above. Okay, so the form that 0 takes this time, I'll start with the original x to the second plus bx plus c. What we're going to do is we're going to create a perfect square trinomial from x squared plus bx. So since the coefficient of x squared is 1, we create a perfect square trinomial by adding the square of b divided by 2. So in other words, b divided by 2 squared is b to the second over 4. And then we subtract the same quantity, b to the second over 4, and then we have the plus c. So this is what is referred to again as adding 0. We can add 0 to something without changing the quantity. We're changing the form, but we're not changing what the quantity represents. Okay, now we have a perfect square trinomial, x squared plus bx plus b to the second over 4. So we can write that as x plus b over 2 quantity squared. So we have a quantity squared. And then for the remaining two terms, the minus b to the second over 4 plus c, we're going to write that as minus the quantity b squared over 4 minus 4c over 4. If you do the arithmetic, you can verify that when we subtract b to the second over 4 minus 4c over 4, that's equivalent to minus b to the second over 4 plus c. Okay, then in the next step, we write x plus b over 2 squared. And then we're going to write this quantity. I need the minus sign, minus. We're going to write this as the square root of b squared minus 4c over 2 quantity squared. So when we square this quantity, the square root of b squared minus 4c over 2, that's equivalent to b to the second minus b to the second over 4 minus 4c over 4. Okay, this is now in the form of a difference of squares. We have one thing squared minus another thing squared. So to factor it, we can just use the difference of squares factoring formula. So one of the factors will be x plus b over 2 minus the square root of b to the second minus 4c over 2. And the other factor is x plus b over 2 plus the square root of b to the second minus 4c over 2. Okay, what we'll do next is we'll use this factoring formula of that trinomial x squared plus bx plus c, and we'll use that formula to factor this trinomial x to the second plus 5x plus 6. Well, if you've done very much factoring, you know that immediately we could find the factors of this. We know that the two factors are x plus 2 times x plus 3. We can verify that by multiplying x plus 2 times x plus 3 to get x squared plus 5x plus 6. But the purpose of this example is to use this formula that we derived by using the difference of squares factoring formula. So for this polynomial, x squared plus 5x plus 6, our value of b is 5, and the value of c is 6. So in our factoring formula, we will replace b with 5, so we get x plus 5 halves, and then minus the square root of 5 to the second minus 4 times 6, all divided by 2. And then in the other factor, we have x plus 5 over 2 plus the square root of 5 to the second minus 4 times 6 over 2. And then we can simplify. So in the next step, we have x plus 5 over 2, and then minus this square root of 5 to the second minus 4 times 6 over 2. Well, let's do some of this in our head. 5 to the second is 25. 4 times 6 is 24. 25 minus 24 is 1, and the square root of 1 is 1. So we get minus 1/2. And then for the other factor, we have x plus 5 halves plus the same number. The square root of 5 squared minus 4 times 6 all over 2 is plus 1/2. And then we'll just take it one step further. X plus 5 over 2 minus 1 over 2 is x plus 4 over 2, but 4 over 2 is 2, so we get x plus 2. And the other factor, x plus 5 halves plus 1/2, is x plus 6 halves, but 6 halves is just 3. So we get the factors x plus 2 times x plus 3. But once again, this is just using an atypical method for factoring the quadratic trinomial. Okay, one more example. So this time we want to factor x to the 4th plus 4x squared plus 16. And a hint is given. Add 0 and then factor a difference of squares. Well, what form should 0 take this time? I'll start with the original x to the 4th plus 4x squared plus 16. And then I'm going to add 0. So the form that 0 takes this time is plus 4x squared minus 4x squared. So we're just adding 0. And in the next step, we'll combine these two like terms, 4x squared plus 4x squared. So we'll get x to the 4th plus 8x to the 2nd. And then we'll rearrange these terms. We'll write the plus 16 and then the minus 4x to the 2nd. X to the 4th plus 8x squared plus 16 is a perfect square. So we can rewrite x to the 4th plus 8x squared plus 16 as x to the 2nd plus 4 quantity squared. And the minus 4x squared, we can write that as minus the quantity 2x squared. So as you can see, we have a difference of squares. Now we just use the difference of squares factoring formula. One of the factors is x squared plus 4x minus 2x. Sorry, I wrote that wrong. X squared plus 4 minus 2x. The other factor is x squared plus 4 plus 2x. And then we'll rearrange the terms in each of those so that each one of those is in standard form. So we have x squared minus 2x plus 4 and x squared plus 2x plus 4. Well, we have a formula that we derived on the previous page for factoring trinomials of these forms. So I'll just rewrite the factoring formula that we derived on the previous page, the x squared plus bx plus c. One factor is x plus b over 2 minus the square root of b to the second minus 4c all over 2. And the other factor is x plus b over 2 plus the square root of b to the second minus 4c over 2. And so using that formula for this first trinomial, the value of b is negative 2. And the value of c is 4. So we'll write, using the formula, x plus b over 2, this will be x plus negative 2 over 2, and then minus the square root of negative 2 squared minus 4 times 4 all over 2. And then the other trinomial, x squared plus 2x plus 4, this time, sorry, we're not ready for that. We have to write down the second factor of x to the second minus 2x plus 4. So this second factor is still using b equals negative 2 and c equals 4, x plus negative 2 over 2, and then this time plus the square root of the number negative 2 squared minus 4 times 4 all over 2. So these are just the two factors of x squared minus 2x plus 4. So let's simplify this product first. And so we get x plus negative 1. So we'll write this as x minus 1. And then minus the square root of 4 minus 16, which is the square root of negative 12 over 2. And then the other one will be x minus 1 plus the square root of negative 12 over 2. And the square root of negative 12 simplifies to 2 times I times the square root of 3. So let's write that as x minus 1 minus 2i times the square root of 3 over 2. And the other factor, x minus 1 plus 2 times I times the square root of 3 over 2. And 2 over 2 is 1, so we'll simplify a little bit more, and we get x minus 1 minus 2i times the square root of 3 over 2. And the other factor is x minus 1 plus, sorry, I was supposed to cancel the factors of 2. So we have x minus 1 minus I times the square root of 3. And then the other one is x minus 1 plus I times the square root of 3. Okay, the only difference between the factors of the other trinomial, x squared plus 2x plus 4, the only difference will be instead of x minus 1, we'll have x plus 1. But otherwise, the terms are the same. So we can write down the final result by taking that into account. So the final result, with a pen that writes x to the 4th plus 4x squared plus 16. We have these first two linear factors, x minus 1 minus I times the square root of 3 times x minus 1 plus I times the square root of 3. And then the two remaining factors will be x plus 1 minus I times the square root of 3 and x plus 1 plus I times the square root of 3. Okay, so we get 4 linear factors. Okay, and that is all for today.